Let's talk now about section 5.1, the remainder and factor theorems, along with synthetic division. For starters, we want to make sure everybody understands what a polynomial equation is. That's what chapter 5 is going to be dealing with, polynomial equations. We've worked with these before. We've worked mostly with linear and quadratics, but we have worked with some cubics and fourth degree polynomials, and even a couple of fifth degree, where we've graphed them, we've found their intercepts, and some of them we've even solved as long as they could be solved by factoring. But in this chapter, we're going to extend our understanding of polynomials and their roots, and we're going to figure out ways that we can solve some of these polynomials even if they're not factorable algebraically. So just to be sure we understand, a polynomial equation is an equation that can be written in the form p of x equals 0, where p of x equals this long list of stuff here. And basically what it's saying is the a sub n's, those are your coefficients, and the coefficients have to be real numbers, and the base is your variable. So in this case, the x is our independent variable, so it's our base, and the exponents themselves, the n's, those have to be natural numbers. So 1s, 2s, 3s, 4s. And typically when we write polynomials, we write them in descending order based upon their exponents and their degree. So the highest power comes first, and then we back down on the powers until we get to the linear term, as you can see right here, the a sub 1 times x, and the constant term. The constant term is noted a sub 0. So that's a polynomial equation. So the first thing we're going to talk about in terms of the polynomial equations is the remainder theorem. The remainder theorem states that if p of x is a polynomial and r is any number, and p of x is divided by x minus r, then the remainder of that division problem has to be p of r. So for example, let's say we take p of x and we divide it by x minus 4. Then that means that if I find p of positive 4, just using function notation and substitute 4 in the place of x, that has to equal the remainder of that division problem that I just worked out. If I took p of x and I divided by x plus 7, that would mean that p of negative 7 has to equal the remainder of that division problem. So it's helpful in a couple of ways. First off, if I only want to know the remainder, instead of actually doing the division, what I could do is I could just find p of this number here and here. That number we call the synthetic divisor. That's the number that makes the divisor equal to 0. And we use it for synthetic division as well as function notation in the remainder theorem. So if I only wanted the remainder, I could just skip division altogether. But I could also use the remainder theorem to check a division problem if I didn't want to multiply the polynomials all the way back out, or if I were low on time, I would know that if p of my synthetic divisor equaled my remainder, there was a pretty good chance that I worked the problem correctly. So let's look at this example. It says, let p of x equal 3x to the third minus 5x squared plus 3x minus 10. And the first thing we're asked to do is to find p of negative 2. So we've been doing that all the way back since at least Algebra 1, maybe even before. We simply substitute every x in our equation, and we put a negative 2 there instead. So if I work that out, I have 3 times negative 2 cubed, which is negative 8, and 3 times negative 8 is negative 24. Negative 2 squared is positive 4 times negative 5 is negative 20. And 3 times negative 2 is negative 6. And then we have minus 10. So let's see what that turns out to be. It looks like we have negative 44, minus 6 is negative 50, minus 10 is negative 60. And also for those of you who have a a nice calculator at your fingertips, you could store -2 in the place of your variable x, and then you could just substitute into the polynomial. But it's also good to work these out by hand. Okay, so that's p of -2. Let's take a look at dividing p of x by x plus 2. If I divide p of x by x plus 2, and for now I'm going to use long division, even though synthetic division is an option, but let's do synthetic division a little later on. Let's review long division for a minute. If I take x plus 2 and make it my divisor, and I divide into my polynomial, 3x cubed minus 5x squared plus 3x minus 10. And I ask myself, what is the leading term here, 3x cubed, divided by x? And that would be 3x squared. Another way of asking that is you ask, what can I multiply the first thing of my divisor by to equal the first term of my dividend? And the answer is still 3x squared. So we're going to put that up there, and it's going to become part of our quotient. And 3x squared times x is 3x cubed, but remember that you have to multiply that term by the positive 2 as well. So 3x squared times 2 is positive 6x squared. Then we're going to subtract that, or the way some of us say it, draw a line and change your signs. Change. The first two cancel, leaving me with negative 11x squared, and I bring down the next available term, which is positive 3x, and I start the division process over again. So what can I multiply positive x by to make it equal negative 11x squared? And the answer is negative 11x. So that will become part of my quotient as well. And then I multiply the negative 11x term by both terms of the divisor, producing negative 11x squared minus 22x. Then I have to subtract that product, so we draw a line and change our signs. That gives us 25x, bring down the minus 10, and start over. So what can we multiply positive x by to make it equal positive 25x? And the answer is positive 25. So we have positive 25 times x is 25x, and positive 25 times 2 is positive 50. But then I have to subtract that off. So if I draw a line and change both of my signs, I get negative 60, and that's my remainder. So notice that the p of -2 was equal to the remainder when I divided the polynomial by x plus 2. So now we need to talk about how to write that answer. There are a couple of ways you can write it. The typical notation is to simply list the quotient, 3x squared minus 11x plus 25 plus the remainder over the divisor. So plus negative 60 over x plus 2. So rather than writing plus a negative, let's just write minus 60 over x plus 2. And that is the typical way of writing the answer to a polynomial division problem. However, for the purposes of this section, it is also going to be important for you to understand that there is an alternate way of writing that. And that is listing the the quotient, which is 3x squared minus 11x plus 25, times the original divisor plus the remainder. So in this case, plus negative 60, which we'll just write as minus 60. Now this one right here, it's not very conventional, and I'm only bringing it up because WebAssign uses it sometimes, so you need to pay close attention to how you're asked to type it in. Now it's also important to note that this notation at the bottom here, that is how you would check the problem algebraically. You would multiply this quotient by this divisor, and then you would add the remainder to it. That's how you check any division problem, is the quotient times the divisor plus the remainder. So it is a legitimate way of checking the problem. It's just not typically how we write the answer. The more typical way of answering a division problem is here, where we just do the quotient and then the remainder over the divisor becomes your final term. Be careful though on WebAssign and make sure you look and really read the question and find out how they want you to type it in. Okay, let's take a look at this example. It says use the remainder theorem. So let's highlight that, the remainder theorem, to find the remainder that will occur when the polynomial p of x equals 2x to the fourth minus 10x cubed plus 17x squared minus 14x minus 3 is divided by the binomial x minus 3. So first, I know your first instinct is probably to just start dividing. Either use long or synthetic division. We haven't covered synthetic division, but we're going to in the next part of this video. So maybe your first instinct is to start off with long division, but read the problem carefully. It's telling you to use the remainder theorem. And the remainder theorem states that instead of actually doing the division, I can find p of the synthetic divisor, which in this case is positive 3. That's the number that makes the divisor 0. I can find that, and that will equal my remainder. So if I'm not interested in the actual quotient, if I'm only interested in the remainder, especially even if I'm in a hurry on, say, the ACT or something, then I could just find p of 3 here, and I could probably narrow down my answers very quickly. So let's look at that. P of 3 is equal to 2 times 3 to the fourth minus 10 times 3 to the third plus 17 times 3 squared minus 14 times 3 minus 3. Now with numbers this large, it may be debatable about whether or not this was faster. But if you have access to a calculator, it certainly would go even faster. But we could certainly do this if we had to. 3 to the fourth power is 81. 3 to the third power is 27. 3 to the second power is 9. And 14 times 3, I can go ahead and work out because I don't have an exponent there, is negative 42 minus 3. So 2 times 81 is 162. 10 times 27 is negative 270. And 17 times 9 is 156. Minus 42 minus 3. And if we tally all of that up, it turns out that it's equal to 0, which is really interesting. So let's stop for a minute and talk about it. Have we answered the question? I was asked to find the remainder, and we know that p of 3 equals the remainder. So in this case, yes, the remainder is 0. But what does it mean for polynomial division when we get a remainder of 0? Well, it actually means several things. First off, it means that the synthetic divisor, that number, positive 3, comma, that y value, 0, is on my graph. Not only is it on my graph, it is an x-intercept. It also means that positive 3 is what we call a 0, sometimes also called a root or a solution. Any number that makes the equation equal to 0 is called a 0, a root, or a solution. So we know that positive 3 is a root or a solution, and those are going to become important much later on in this section. The final thing we know is that when I divide by x minus 3, the remainder is 0, which means that x minus 3 is a factor of our polynomial. So there's a lot going on in that problem. Okay, let's break for a minute and then we'll get started on the factor theorem and synthetic division.